Assalamualaikum. This is again Miss with the chemistry lesson today. I hope you enjoyed my previous lesson. Before starting, I want all of you to be seated. You all should have your notebook, a pen, calculator, as well as your periodic table with you. So let's get started. So what do you notice? What do you see on your screen? 2 atoms, right? What do you notice about the atoms? 2 sad atoms, right? What else do you notice about the atom? Yes, one atom is having 1 electron in its valence shell and the other is having 7 electrons in its valence shell. So that means one element is from group 1, right? And the other element is from group 7. Now, why do you think are these atoms sad? Yes, the atoms are not stable, right? How can we make these atoms happy? Yes, by making it stable. So, how can we make the atom stable? Yes, the 2 elements need to undergo a chemical reaction. So, during that chemical reaction, the sodium atom will be transferring its valence electron to the chlorine atom. So, sodium will form a positive ion and chlorine will form a negative ion. Sodium ion is the cation and chloride ion would be an anion, right? So, when these 2 atoms react, an ionic compound will be formed with stable happy ions. By the end of today's lesson, all of you should be able to draw the structure of any ionic compound given. You should be able to deduce the formula of ionic compounds. You should be able to define what an ionic lattice is, as well as you should be able to state some physical properties of ionic compounds. So let's see how ionic compounds are formed. Now you can see the structure of sodium and chlorine. You can see that sodium is having 1 electron in its valence shell and chlorine atom is having 7 electrons in its valence shell. So how do you think chlorine and sodium will obtain a stable electronic configuration? Yes, sodium will be transferring its valence electron. You can see sodium is transferring its valence electron to the chlorine atom. So sodium will gain a stable electronic configuration as well as chlorine. So this would be the structure of sodium ion and chloride ion. I have explained this in the previous lesson, right? Sodium is forming a plus, so Na plus ion, and chloride, since it is gaining 1 electron, it is forming Cl minus. So when you draw the dot and cross diagram, instead of drawing all the shells of the positive ions, you can just draw square brackets Na and then you can write a plus charge. And in the chloride ion as well, you can just draw the valence shell, write Cl and then draw the electrons with a minus charge. Okay, so this would be the final dot and cross diagram of sodium chloride. It's a very frequently asked question in the theory paper. You should know how to draw the dot and cross diagram of any ionic compound given. So you should draw the positive ion first and the negative ions. You should draw only the valence shell unless it is asked in the question. So you also need to know how to deduce the formula of the compound by looking at the dot and cross diagram. So what do you think would be the formula of sodium chloride? It's just one sodium ion and one chloride ion, right? So this would be the formula of sodium chloride, NaCl. So NaCl is the formula of sodium chloride. So let's look at another example. This time let's see magnesium oxide. Magnesium oxide. So magnesium, when you write the electronic configuration, it's 282. Oxygen, it is 2,6. Oxygen atom needs 2 electrons to obtain a stable electronic configuration, and magnesium atom needs to transfer 2 electrons in its valence shell. So when magnesium reacts with oxygen, this is what happens. So magnesium will be transferring its valence electron to oxygen. So this will be the final dot and cross diagram. Magnesium Mg2 plus and oxide would be 1, 2, 3, 4, 5, 6 and 7, 8. So this will be the dot and cross diagram of magnesium oxide, and the formula of magnesium oxide will be MgO. Since the charge of magnesium is Mg2 plus and the charge of oxide is 2 minus, the charges will cancel out and the final formula would be MgO. Let's look at magnesium chloride. In this example, I will first explain how to write the formula of ionic compound and then how to draw the dot and cross diagram of the compound. So as a first step, you need to write down the formula of the ions in the ionic compound. So magnesium is an element from group 2. So the formula of magnesium ion will be Mg2 plus. And chlorine is an element from group 7. So the formula of chloride will be Cl minus. I have already explained this, right? You can use the group number to deduce the charge in the ion. So Mg2 plus and Cl minus. As a next step, you need to find out the valency. So valency of magnesium is 2, valency of chloride is 1. And then as a next step, you need to interchange these valencies. So when you interchange the valency, this is how it will be, and formula of magnesium chloride will be MgCl2. So the charge of magnesium is going to the chlorine, or the valency is going to the chlorine atom MgCl2, showing that 2 chloride ions are bonded to 1 magnesium atom, right? So when you draw the dot and cross diagram, you need to write Mg and formula of magnesium ion is 2 plus, right? Just write Mg2 plus, and then you can draw the chloride Cl and draw the electrons. And since there are 2 chloride ions, you need to write a 2 here, and the charge is Cl minus. Let's look at another example. So here is lithium and nitrogen atom. Lithium is having 1 electron in its valence shell and nitrogen is having 5 electrons in its valence shell. Nitrogen needs 3 more electrons to obtain a stable electronic configuration, right? But each lithium atom, as you can see, lithium atom is having 1 electron in its valence shell, which means one lithium atom can only transfer 1 electron to nitrogen. So there should be 3 lithium atoms, as you can see. So each lithium atom transfer its valence electron to nitrogen. So this would be the structure of lithium ion. As you can see, 3 lithium ions and 1 nitrogen ion, 1 nitride ion, right? Nitrogen atom has gained 3 electrons forming a nitride ion. So this will be the final structure of lithium nitride. That would be the ionic compound, lithium nitride. So also you can draw the structure as just 1 lithium ion, and then since there are 3, you can see 3 ions, right? You can just write 3 Li plus and then a nitride ion. So 1, 2, 3 and 4, 5, 6, 7 and 8. So write n and square brackets with a 3 minus. So this will be the dot and final dot and cross diagram of lithium nitride. Very easy, right? So to deduce the formula of lithium nitride, you can see 3 lithium ions, right? So you can write Li3 and N, Li3N, lithium nitride. So that would be the formula of lithium nitride. Is it clear? So let's look at another example. Here you can see the final dot and cross diagram of aluminium oxide. When you write the electronic configuration of aluminium, you will know that aluminium is 283, right? And oxygen is 6. So aluminium needs to transfer 3 electrons to obtain a stable electronic configuration, and oxygen needs 2 more electrons to obtain a stable electronic configuration. So when aluminium and oxygen bonds, when aluminium and oxygen forms an ionic compound, there would be 2 aluminium ions and 3 oxide ions, as you can see in the diagram. So this will be the final dot and cross diagram, and if when you deduce the formula of aluminium oxide, that would be, since there are 2 aluminium ions Al2 and 3 oxide ions Al2O3. So this will be the final dot and cross diagram of aluminium oxide, and this will be the formula of aluminium oxide. As a last example, I will be looking at potassium sulfide. Potassium is an element from group 1, right? So the formula of potassium ion would be K+. Sulfur is an element from group 6, right? So the formula of sulfide ion will be S2-. So potassium is having a charge of +1, sulfide it's -2. So valency will be 2, and then you need to interchange the valency, which means the valency of sulfur will go to potassium and the valency of potassium will be going to sulfur. So the formula of potassium sulfide will be K2S. It's K2S, right? Is it clear? Then you can draw the dot and cross diagram of potassium sulfide. So potassium is K plus. So that is potassium ion, and sulfide is S2 minus, right? With an overall charge of 2 minus and then S. So this will be the final dot and cross diagram of potassium sulfide, and this will be the formula of potassium sulfide. Now you have studied some examples of ionic compounds, right? Sodium chloride, magnesium chloride, aluminium oxide, and some other examples. You have just studied one ion, one positive ion and one negative ion from each compound. However, in a 3D space, there is a bulk of positive and negative ions known as a lattice. So a lattice is a regular arrangement of alternating positive and negative ions. Sodium chloride is an example of an ionic lattice. So ionic lattice will have a regular arrangement of positive and negative ions. So as an example, let's look at how sodium chloride ions are arranged in real. So in this, assume that these red pieces are sodium ions, these black pieces are chloride ions, and these white pieces, these are ionic bond. So from this as well, you will notice that to each there are 6. So since assume that this is a chloride ion, so to this chloride ion there are 6 sodium ions attached. Likewise, to each sodium ion there will be 6 chloride ions attached. So this is how sodium chloride structure is. This is the ionic lattice, sodium chloride. This is how it is. To each sodium ion there will be 6 chloride ions attached, and to each chloride ion there will be 6 sodium ions attached. Now we have looked at how to draw the dot and cross diagram of ionic compounds, how to deduce the formula of ionic compounds, as well as we have looked at what an ionic lattice is, right? So next we will be looking at some of the physical properties of ionic compounds. So ionic compounds have a high melting and boiling point because the oppositely charged ions in an ionic compound are held together by strong electrostatic force of attraction. So oppositely charged ions in the lattice structure is held together by strong electrostatic force of attraction. So a lot of energy is needed to separate the ions. Next, ionic compounds are usually solids at room temperature because ionic compounds have a high melting and boiling point. Ionic compounds are usually soluble in water because water is polar, as well as the ionic compounds have free ions. And ionic compounds conduct electricity in molten state as well as in aqueous solution or when dissolved in water, because the ions are free to move and the ions can carry the charge. So basically, ionic compounds have a high melting and boiling point are usually solids at room temperature, are usually soluble in water, as well as ionic compounds conduct electricity in molten state and in solution. So that's it for today. I hope you enjoyed the lesson. Thank you.